Is my screen visible?
Yes, sir.
All right then. So we will start with another topic. This is also a direct integration method. Last class we have seen the central difference method. This is today's lecture will continue with the Houbolt method. Most of the methods which are covered in this particular category, they have a similar pattern. So here also you have a similar pattern in which like you have to go for the initial calculations first, and then we have to go for the stepwise calculations. So more or less process is similar. So we will just quickly go through the process. The very first thing is you have to find out what are the stiffness matrix, what are the mass matrix, and what is the damping matrix C. So these three matrices will be given to you, and if any of the matrix is not given to you, then you have to solve that, and you have to get the values. Then when t is equal to 0, that is the initial condition. So initial condition must be known to you. That is the what is the displacement, velocity, and acceleration at t is equal to 0. That should be known to you. So most of the time these values will be given. If any of the value is not given, in that case you have to calculate that value. Then we have to calculate the integration constants. So earlier in the central difference method, there were six integration constants, but in the Houbolt method, there are nine integration constants. So right from A0 to A7, sorry, there are eight, not nine, eight integration constants. So all those integration constants, they are calculated by substituting the values in the equations, and mostly they have a delta t terms in their equation. Now, in this Houbolt method, what we need is the time, okay, or not the time. We need the displacement, and we need the displacement at different time intervals. Like when t is equal to 0, we will be needing a displacement, but at the same time, we will be needing what is the displacement at t is equal to delta t, and what is the displacement at t is equal to 2 delta t. So without this, we cannot proceed further. Like in central difference method, what was given? So if t is equal to 0, at that time, if displacement is known, so in the central difference method, what we used to do, we have to calculate what is the displacement at one step prior to the current time, that is t is equal to minus delta t, and then we can proceed further. But in the Houbolt method, what we need is what is the displacement at t is equal to 0, what is the displacement at delta t, and what is the displacement at 2 times delta t. So this delta t and 2 times delta t, the displacement value, that we have to calculate first with the central difference method. Then and then only we can go ahead, and then we can proceed further using the Houbolt method. So this is the initial calculations which you have to do, and for that purpose we have to use the central difference method only. Then lastly, we have to generate the effective stiffness matrix. If you remember correctly, in the central difference method, we have calculated effective mass matrix. But in the Houbolt method, we have to calculate the effective stiffness matrix. The equation is there in front of you. That is, effective stiffness matrix is nothing but the stiffness matrix K plus A0 times M, that is the mass matrix, plus A1 times C, that is the damping matrix. Okay. So this is your initial calculation. Once the initial calculations are done, in that case, you have to go for the stepwise calculation. Now in the stepwise calculation, there are only 4 steps. The first thing is you have to calculate the or you have to solve the stiffness equation. For that purpose, you have to go for the effective load vector. So effective load vector we have already calculated in the earlier central difference method, but here the equation is slightly different. So the effective load vector at t is equal to delta t is nothing but the load vector at t, then mass into this huge equation, and then damping matrix into this huge equation. Okay. So once this is known, then you can calculate the, or you can solve the stiffness equation, that is k into displacement equals to force. Okay. And once this thing is known, you can get the value of unknown displacement at t is equal to delta t, and then we can go for the calculation of velocities and also calculation of the acceleration. Okay, so these are the standard equations which we have to use in calculation of the response of the structure. And we'll just take a simple problem which we have already covered in the central difference method, because we will be requiring the values of central difference method. Okay, so if you remember correctly, last class we have taken this particular problem, that is what is the 4 times u dot u double dot, that is 4 into acceleration plus 2 into velocity plus 1 into stiffness, that is k, equals to 8, and we have calculated the response of the structure. Okay, so let us quickly go through the uh, solution of this one. So I hope this is clear to everybody. Any questions? Let us start the numerical then. So let me share the, okay, is my screen visible now? Okay, दिख रहा है?
Yes, sir.
Okay, okay, so let us start. Okay, so our problem was something like this. It was like 4 times u double dot plus 2 times u dot, okay, plus u equals to 8. So this is the equation which is given to you, and what is given to you, that is at t is equal to 0, we know the displacement is 0 and the velocity is also 0. Okay, so this is given to you, and what we have to find out, the response of the structure. So capital T is given to you, capital T is 1 second. Okay, and the delta T, so this is your delta T. Delta T is given to you as capital T by 5, so that is 1 upon 5, so this becomes 0.2 second. Okay, so this is given to you. Okay, so now we have to go for now part 1. Okay, so part 1 is initial calculation. Okay, so when I say initial calculations, I should know all the values. So here your stiffness matrix K will be 1. Okay, because here you find there is a 1 over here. Okay, then we have the damping matrix C. So damping matrix C is nothing but the 2, which is given over here. So this is your K matrix. Okay, then we have the mass matrix M. Okay, so this mass matrix M is given to you as 4, and the load vector R. Okay, now this load vector R is given as a constant, it is not changing with the uh, time, so we can consider this as constant. Okay, then when t is equal to 0, so let me copy and paste the table which we have already written in the central difference method. Okay, so this is that table. Okay, if you remember, uh, why it is not moving. Okay, let me insert the table one more time. So now we have okay, this is much better. Okay, so what is known to us is this one. Okay, so let me delete this. Okay, so this is what we have done in the previous class. So what we have to do is we have to calculate the displacements, right? So as per the problem, when t is equal to 0, so this t is equal to 0, we already know the displacement is 0 and velocity is also 0, but we don't know what is the acceleration. So for this purpose, what we are going to do is we are going to calculate this value. So I can write 4, okay, and the acceleration at t is equal to 0 is still unknown, so I'll keep it as it is. Plus this is 2, and the velocity is 0 over here, plus 1 into the displacement. So displacement is 0 over here, equals to 8. And so if you solve this, so the acceleration at t is equal to 0, it comes out to be 8 divided by 4, so this comes out to be 2 over here. So at t is equal to 0, okay, so you can refer to this column. When t is equal to 0, the displacement is 0, the velocity is 0, and the acceleration is also now 0. So this completes the first step of a problem, that is the calculation of the initial conditions. Okay, so the part one, the first step is complete. Now in the second step, you have to go for the calculations of the integration constants. Okay, so let us quickly calculate the integration constants. So this integration constants, we have something like a0. Okay, so a0 is coming out to be 2 divided by delta t square. So this is 2 divided by delta t square. So this is 2 divided by zero point 0.2 square. Okay, so how much is this? Anybody? कितना आ रहा है?
50.
Sorry, 50.
50.
Okay, so this is coming out to be 50. Okay, then we have something like a1 also. Okay, so this a1 is 11 by 6 delta t. So this is 11 by 6 times delta t. So how much is this? कितना आ रहा है?
9.167.
167. Okay, then we have a2 also. So a2 is 5 divided by delta t square. So how much is this?
125.
Sorry, 125.
124.
Okay, so this is 125. Okay, let me just move down. Then we have a3 as 3 by delta t. So this is a3 is 3 upon delta t. How much is this?
15.
15. Okay, then we have a4 as minus 2 times a0. Okay, so 2 times a0 is 50, so this will be definitely minus 100. Okay, and we have a5 as minus a3 by 2. Okay, so 15 by 2 is minus 7.5. बराबर है? Okay, then we have a6 also. So this a6 is a0 by 2. So this is a0 by 2. So this definitely is 25. And we also have the a7 values. Okay, so a7 value is a3 divided by 9. Okay, so a3 is 15. 15 divided by 9, it comes out to be 1.667. Okay, so all the values are correct now. Any questions as far as this part is concerned? No? Okay, so now here the integration constants are successfully calculated. Now as per the process which is there in the Houbolt method, we have to calculate the displacements. Okay, so here you see when t is equal to 0, we already know what is the displacement. Okay, but we have to calculate what is the u at t is equal to delta t, what is the u at t is equal to 2 times delta t. Okay, so this we have to calculate using central difference method. Okay, so here you have to go back, follow the central difference method, or you have to do two steps. Okay, you have to use two steps of the central difference method so that we can get the values of the unknown displacements at t is equal to delta t and at t is equal to 2 delta t. So in short, if I move this table down, so here after that what you will be getting is this one. Okay, we don't require values of the unknown of we don't require the values of the acceleration and the velocity, so I have deleted them. So basically what I have done, these values are given to us. Okay, so these values were given to us. This value was needed for calculation of the central difference method, unknown values of the displacements. So I have calculated what is the displacement at delta t and what is the displacement at 2 delta t using the central difference method only. But from this point forward, that is 3 delta t, we will be using the Houbolt method. Okay, so here only these two values. So these values I can say that these values I have calculated using the central difference method. Now once these values are known to you, all you have to do is just follow the process of the central difference method, and then you can get the values. Okay, but before that you have to calculate the effective stiffness matrix. Okay, so your effective stiffness matrix has to be calculated only once. Okay, so let me write down the equation for the effective stiffness matrix first. So effective stiffness matrix, that is K. Okay, there is a cap above this, so this can be calculated as the stiffness matrix K. Okay, plus a0 times the mass matrix. Okay, plus a1 times the damping matrix. Okay, so your K matrix, that is your stiffness matrix, is basically 1. Okay, plus a0 value we have just now calculated as 50. Then your mass matrix is 4. Okay, plus a1 is 9.167 into this C, that is the damping matrix, that is 2. So if you solve this, then your effective stiffness matrix coming out to be how much? Somebody please respond.
218.334.
21.
8.334.
एक बार चेक करो तो आई एम गेटिंग 219.334.
Yes, sir.
Sir,
219.334.
Okay, so 219.334. I think you have not considered the K, that's why you are getting 218. Okay, so anyway, so this is the initial calculations. Okay, so this is your part 1 is now complete. Okay, so we have successfully completed part 1, so now we have to go for the part 2. Now in the part 2 we have to just go for the calculations of the stepwise calculation. So this is your part 2. Okay, so I can say this is stepwise. Okay, so now here we have already calculated the response of this structure for t is equal to delta t and t is equal to 2 delta t. So there is no need to recalculate it once again. So we can directly start what is the response of the structure at t is equal to 3 times delta t. Okay, because delta t and 2 delta t response we have already calculated. Now, if you want to calculate the response of the structure at 3 delta t, first thing is you have to calculate the uh, effective load vector. So your effective load vector can be calculated by this expression. Okay, so this expression I have already shown you. So I am just writing it down. I am just rather copying and pasting it from the Word file. So this is the effective load vector at t. Here you can see this is t is equal to 3 plus delta t, and this is the r value. Okay, so this r value is nothing but your 8. So this is given in the problem. Okay, let me use some different pen so that you can understand it in a better way. And this mass matrix, so mass matrix is also given to you in the problem as 4. the A2 value, we have already calculated A2 value as 125. Okay, then here we need to have what is the displacement at t plus delta t. Okay, t is equal to 0 right now, so 0 plus 2 delta t. So 2 delta t value we have already calculated using the central difference method, that is 0.152. Okay, so this value will become 0.152. Then the A4 value, so the A4 value we have already calculated as 100. Then we will be needing the displacement at 0 plus delta t. So 0 plus delta t is nothing but this value, okay, that is 0.04. So all we have to do is here you just write down this value as 0.04. Then the A6 value we have calculated as 25, and the displacement at t is equal to 0. So this is already given in the problem as 0 over here. Okay. Then the C matrix, that is the damping matrix, is given to you as 2. Okay. So let me write down 2 over here. Then this A3 we have calculated as 15. Then this is the displacement at t equals to delta 2 times delta t. So 2 times delta t is once again this value, that is 0.152. Okay, so here I can directly write down over here as 0.152. Okay, then your A5 value is calculated as 7.5. Okay, then we have the unknown displacements, or the displacement at t is equal to delta t as 0.04. So this is calculated over here using the central difference method. Then we have the A7 value. Okay, so your A7 value is something like 1.6667, and lastly the displacement at t is equal to 0, this is 0. Okay, so if you solve this, so what you are going to get is the effective load vector, okay, at t is equal to 3 times delta t. Okay, so 3 times delta t, that is at this particular location in which we are calculating. So at this level we are getting the effective load vector. So how much is that value? Anybody? I'm getting something like 71.96.
So A is negative.
Sorry,
A5. A5 is negative.
A5 is negative.
Negative. Minus 7.5.
This is minus. Okay, fine. Are you getting 71.96? Yes. Anybody? Is it okay? 71.96? Yes, please respond.
Then after that R plus M into A2, there it is plus sign in between before U. हेलो
हाँ बोलो.
सर ये M into A2 के बाद में प्लस का साइन है U
हाँ
के
ये
पहले.
प्लस का साइन है ना इधर.
नहीं उसके सामने.
सॉरी,
सर उसके आगे U के आगे M into
M
A2.
into ब्रैकेट है वो.
अच्छा पूरा ब्रैकेट है.
हाँ हाँ. So this is a round bracket. Okay, so this is a
Okay.
round bracket over here, here and here.
Okay sir.
Okay, so this is one term over here, यहाँ से लेके यहाँ तक, this is one term. Then we have plus, then we have another term, and then we have plus, and then we have another term. Yes, somebody please. 71.96, are you getting this?
Sir, it is coming out to be 103.96.
103.9, please check. Please check once
Yes,
again.
sir.
Sir, I have checked
103.96.
once or twice, लेकिन आंसर चेंज ही नहीं हो रहा. 103.96.
Okay, शायद इक्वेशंस
Some
ठीक
value
लिखने के
must
हमने.
have been.
देखो, this is 8, then 4, then 125, then 0.5, then 100, then 0.04, then 25 with 0, then we have 2, then 15, then this is minus 7.5. Okay, I think this is minus 100. This is minus 100.
Minus 100.
A4. Yeah, A4 is minus 100. You can see over here. Okay.
So yes, sir. Then
Yeah.
171.96.
I guess this is okay now.
Yes, sir.
Okay.
Yes,
Fine.
sir.
So we have now calculated the effective load vector R at this level, that is the delta 3 times delta T level. Okay. Then now we have to calculate the we have to solve the stiffness matrix so that we can get the unknown displacement. Okay. So this unknown displacement can be calculated by a simple expression which is written over here. So we have, let me write it down, that will be better. Okay, so what we have to do is we just have to go for the effective stiffness matrix K multiplied by the displacement at T is equal to 3 times delta T equals to the effective load vector R at T is equal to 3 times delta T. Okay, so earlier we have already calculated our effective stiffness matrix as 219.333. This we have already calculated. Okay, and then now we can calculate the displacement at 3 times delta T equals to the effective load vector R, that is 71.96. So if you solve this, so you can get the displacement at T is equal to 3 times delta T. How much is this? Anybody? 0.328. Is it so? Is it okay?
Yes, sir.
Yes, sir.
So this is the displacement. So this is the final answer. So I am going to write down over here. So this is 0.3281. Okay. So this value, I'm keeping it something like this. Okay. So finally, at the end of this step, what we are getting is the unknown displacement at the delta 3 times delta T. Okay. So this value is now known. Now, let us try to find out what is the velocity and what is the acceleration at that particular time step. Okay. So in order to calculate the say velocity, we will be using a simple expression which is like this. So here, let me expand this. Okay, so the velocity, so this will be the unknown term. Okay, so this is nothing but your a1. Okay, so let me use some different color over here. So a1 value, so if you refer the integration constants, so a1 comes out to be 9.1667. 9.1667. Okay. Let me take this table down so that you can see the values. Okay. Then this is the this is the displacement. Okay. So this has to be multiplied with the displacement at delta t, oh sorry, 3 times delta t. So 3 times delta t, this is the value just now we have calculated over here. It is 0.3281. Okay. Then we have minus a3. So here you see there is a minus sign. Okay. So here, this is a minus sign. So your a3 is coming out to be 15. Okay. So earlier we have already calculated this. Then we have what is the displacement at 2 delta t. Okay. So at 2 delta t, we have used central difference method, and then we have calculated the displacement value as 0.152. Okay. Then there is a minus term once again. Then we have a5. Okay. So a5 value is minus 7.5. Okay. So this is minus 7.5, and the displacement at delta t. Okay. So displacement at delta t we have calculated using the central difference method as 0.04. Okay. Minus a7. Okay. So again there is a minus sign. So your a7 value was 1.667. So this is 1.6667, and the displacement at 0, this is already given in the problem as 0. So if you solve this, you are going to get the velocity at 3 times delta t. Okay. So can someone tell me how much is this value, please?
Sir, 0.4276.
नहीं, गड़बड़ है. Please check.
1.
It should be something like 1.0276. Is it so?
Yes, sir. Yes, sir.
1.0276. Okay. So this is the velocity. Okay. So this will be 1.0276. Okay. So this is the velocity. Now similarly, now you can calculate the acceleration also. So for calculation of the acceleration, the equation is like this. Okay. So let me copy and paste the equation. This is a simple expression, so you can see. Okay. Okay, so we will be needing all those values one more time. So adjust the screen. Okay, so we have to calculate what is the acceleration at t is equal to 3 times delta t. Okay, so for this we will be needing the a0 term. Okay, so this a0 term we have initially calculated as 50. Okay, so this is 50. Then the displacement at 3 delta t, so this we have already calculated just now. So this is 0.3281. Okay, then again you remember there is a negative symbol, and then multiplied by a2. Okay, so a2 is 125. Then what is the displacement at 2 delta t? So 2 delta t we have already calculated using central difference method as 0.152. Then again there is a negative symbol, and your a4 value is minus 100. Okay, you see there is a negative symbol, and there is a minus sign, or minus 100 also. So it will become plus, multiplied by the displacement at delta t. So delta t is 0.04. So this we have calculated using central difference method. Then again there is a negative symbol, and then it will be multiplied with a6. Okay, so a6 is 25, and the displacement at t is equal to 0 is already given to you as 0. Okay, so the velocity, the acceleration value at 3 times delta t, how much is this? Somebody please.
1.405.
1.405. Okay, so this comes out to be कहाँ गया? 1.405. Okay, so this is the acceleration. So this is 1.405. Okay, so this completes the calculation of the response for the one more step. Okay, that is the 3 delta t. Okay, so this is the 3 delta t. So now I want all of you to calculate the what is the response of the structure for the 4 delta t. Okay, so this completes the 3 delta t. So let me draw a simple line over here. Okay, so this part is now over. Okay, so now we will be working on time at as 4 times delta t. Okay, so if you want to go for the 4 times delta t, the first thing you have to calculate is what is the effective load vector r. Okay, so r we have to calculate. So the effective load vector r at that particular time, that can be calculated using a simple expression which we have already seen in the earlier one. Only thing is now everything will be, or the every value of delta t will be incremented. Okay, so this will be, if you refer this equation over here, so here you have t is equal to 0. Okay, so here you will be having t is equal to 0 because the r is constant. But as far as these equations are concerned, so like here you will find that the displacement is at 3 times delta t multiplied by a2. Here you will find displacement at 2 times delta t multiplied by a2. So everything it will be incremented by 1. All you have to do is just substitute the values, and then you can calculate what is the value of r, that is effective load vector, at 4 times delta t. Okay, so all the values are there with you, so please let me know the value of effective load vector r. Meanwhile, I'll just mark your attendance. Roll number 14 is absent, I suppose. Piyush. Then roll number 16, Shashwat Nibude. And roll number 18, Saurabh Chaudhary. I think Nidhi Ingole is absent. No, she is there. Okay. Okay, Nikita Lode is there. Pratiksha is also present. Avinash is also present. Bhaumik is also present. Then Jayant Tanjankar is also present. Nakul Bakde is also present. Sagar Zade, I think Sagar Zade is absent. And Suwan Paul is also absent. Okay. Yes. इफेक्टिव लोड वेक्टर आर आ गया तो आप लोगों का, एनीबॉडी? स्ट्रक्चर इंजीनियरिंग स्टूडेंट्स, तुम लोगों का 10 बजे पेपर है क्या?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है, जल्दी जल्दी कैलकुलेशन करो देन. अरे आर तो निकालो भाई. एनीबॉडी? All you have to do is just substitute the values. Okay, it's not that difficult. करो फटाफट करो. Okay, I'm writing all the values.
So 123.42.
123.42, something like that. I'm getting 122.9, but 123 will also do. No issue. And this last value, I think this is 0.04. Okay. So how much is this R value you are getting? 123.
122.94.
122.9463.
122.94. This is what I am also getting. Okay. 122.9. Okay. So if this value is correct, so we can proceed ahead. And lastly, all we have to do is calculate the unknown displacement. So for that purpose, you have to use the effective stiffness matrix multiplied by the displacement at 4 times delta t. Okay, equals to, you have effective load vector R at 4 times delta t. Okay, so if you substitute the values, so your stiffness matrix K, this is constant, so this is 219.334. Okay, and then this will be unknown, so this will be unknown, and this value is 122.94. And so if you solve this, okay, so all you are going to get the displacement at 4 times delta t as कितना आ रहा है?
0.5605.
Yes. So this is 0.5605. So here you have 0.5605. Okay. So similarly, now you can have the calculations for the velocity as well as the acceleration. Okay. So I'll just write down the expression for the velocity. Okay, so for that velocity term, you have to use a expression which is something like this. Okay, so all you have to do is just substitute the values in this expression. So the value of a1 is something like this. Okay, so your a1 value is 9.167, 9.1667. Then this displacement just now we have calculated as 0.5605. Okay, then this a3 is 15. Okay, and the displacement, this is at 3 times delta t, that is 0.3281. So you can refer a table for this. Then we have a5, so a5 is negative 7.5. Okay, and this value, I think it is 0.152. This is calculated using the central difference method. And a7 value is 1.667. Okay, and this value is already given to you as 0. So if you solve this, So you are going to get the velocity at 4 times delta t. बताओ कितना वैल्यू आ रहा है?
1.2899.
Let me check. 1.2899. Okay, so this is 1.2899. Okay, so here now I can write something like 1.2899. Okay, so this completes the calculations for the velocity. So now you can do the calculations for the acceleration also. Okay, so acceleration, the equation will be very much similar to the equation which is there earlier. Only thing is now one delta t will be added in every term. Okay, so this is the term over here for the equation for the acceleration. Okay, so your a0 term, so a0 term we have calculated earlier as 50. Okay, and this is the displacement which we have calculated in this state. So this is 0.5605. Okay, this is prior to that, so this is 0.3281, and this is something like 0.5, sorry, 152, and this is basically 0. Okay, and your a2, so your a2 is 125, then your a4 is minus 100. Okay, and your a6, okay, so a6 is 25. So if you solve this, you are going to get the acceleration at 4 times delta t.
1.2125.
1.2125, correct. Okay, so I'm going to write down over here, so 1.2125. Okay, so this is how the method is going to work. So you can proceed further in the similar pattern, and then we can get the response at a time interval that is 5 times delta t. Okay, so all you need to understand that in the Houbolt method, the response of a structure for delta t and 2 delta t will be calculated using the central difference method, but the rest of the response will be now calculated using the Houbolt method equations, and 3 times delta t, 4 times delta t, 5 times delta t, and so on. Everything will be now calculated using the Houbolt method. Okay, so in short, you will have at the end of your calculations, you will have a table which is similar to this one. Okay, so let me copy and paste the table over here. Okay, so here you see these two values. Okay, so these two values will be calculated using the central difference method, and rest of the value, that is the 0.3 delta t, then 4 delta t, 5, 6, 7, 8, this we have already I have already calculated using a computer program, and you can see the values are there calculated using the Houbolt method. They are matching with the our calculation. So if you see our calculations, we have done the calculations for 3 delta t and 4 delta t, so we have done the calculations for this one. Okay, so there is a slight difference, like if you see the acceleration value, you are getting something like 1.2125, and I am getting 1.2148. So this may be due to the round of error, but if you continue further for the calculations of displacement, velocity, and acceleration for the 5 delta t, 6 delta t, and so on, so you are going to get a values very much similar to this one. Okay, so I think we can stop over here. Is there any questions as far as this part is concerned? Yes, anybody? No?
No, sir.
Okay,
How to remember the formulas?
याद तो करना पड़ेगा बेटा अभी. In some of the question papers, if you see, the integration constants and equations are given. Okay, but you to be on safer side, you have to remember all the equations, and you have to remember all the integration constants. So just in case if they are not given, then otherwise you will be in trouble. So it's better you remember all the constants and all the equations. And if you see the previous year's question paper, mostly the central difference method is asked, and that too in an option. So you will always get this question in an option. but there are some papers there you won't find any choice which is given to this problem. Even if the choice is given, so sometimes I have seen like central difference is given first choice and Houbolt method is given as a second choice. Okay, so there is no escape. You have to learn this. Okay, and you have to solve the problem. Okay, so
Only 40 marks paper will be there.
sorry.
40 marks paper semester.
Ha.
Okay.
Correct.
And
Okay. See, I think everybody has submitted assignment 1, assignment 2, assignment 3, and assignment 4, isn't it? Most
yes,
of
sir.
you have submitted the assignment 5 also. Okay. So everybody should submit the assignment 5. Those who have not submitted, please submit the assignment 5. Okay.